Okay, so we are going on to advanced reflections and rotations. We've actually already done advanced dilations. That was last Thursday. So now we're moving on to reflections and rotations. So what does it mean when we say advanced? It means the line of reflection might not be horizontal. It might not be vertical. It might not be y equals x, that parent function. So the line of reflection and the center of rotation could be anywhere now. All bets are off. They could be anywhere. So how are we going to find the line of reflection? So on your notes page, you are going to follow these steps right here, which I hope you've already done because I gave you time. You should be using a ruler, and you should connect. Let me use my segment tool, so mine's straight. You want to always begin by connecting points from the image to the corresponding parts of the preimage. So F connects to F prime, E connects to E prime, and H connects to H prime. If you notice, G lies on the line of reflection, so G and G prime are one and the same. All right, then it asks you to measure these angles. Measure us some angles. And hopefully when you use your protractor and you measured those angles, you got 90, 90, 90, right? That was not a coincidence. This happens every time. Then it said measure the length of each segment, and then measure the length of the shorter segments formed when the line of reflection passed through them. So you were to measure FF prime, and then you were to measure those little parts, and you should have discovered that that segment was cut in half, and we have a fancier word for that. So at the bottom, it said to make a conjecture. The line of reflection is ... The line of reflection is, what do you think? It's a word that we learned actually the first week of school. It's a two-word vocab word. Is the blank blank. There we go. That's what I was looking for. The line of reflection, this is actually in your notes, like the table notes. All the answers are in the fourth column. The line of reflection is the perpendicular bisector of each segment joining the point in its image. So this line, M, he used the special one. M is the perpendicular bisector of FF prime, EE prime, and HH prime. It cuts them in half, and it intersects them at 90 degrees. So, armed with that knowledge, we are going to see if we can draw the line of reflection ourselves, now that we know that the line of reflection is the perpendicular bisector. Now, how do we always begin these problems? We always begin by connecting the corresponding points. That means connect A to A prime, connect B to B prime. Yep, connect the dots. Pretend I'm using a straight edge. This is really bad to not use a straight edge. Okay. Now, there's 3 ways to do this, and I gave you time to kind of think about it. I hope that's what you were doing when I was showing these slides, but I want to go over the 3 ways that you can do this. I'm just going to go ahead and tell them to you. You're welcome to write these down next to the picture in your notes, okay? Way number 1, I'm just going to go ahead and start with the most sophisticated way, the way that geometry was designed kind of to do it with the tools that you were given. So the first way is I would construct the perpendicular bisector using a compass, which in that case, if you were doing it this way, you would only need to have connected 2 of the dots. Connected any 2 of the dots, and you could have done it this way. Let me remind you how to construct a perpendicular bisector. I'll do it to this one, but you could have done it to any of them. You put the needle on one end point, and you open up more than halfway. You draw an arc. Then you keep your compass at the same setting. You put your needle on the other end point, and you make the arc facing the opposite direction. And then you take a straight edge, and you connect the intersections. And this segment right here would be, what it say to call it L or something? That segment would be the line of reflection. So that's way number 1. you can construct a perpendicular bisector with a compass. Way number 2 is you could use a ruler, and you could measure AA prime and measure BB prime, and you could, I'm going to put ruler, you could find midpoints. You would only need to find 2 midpoints, right? Because through any 2 points, there's only one line. So if you were to find the midpoint of AA prime and the perfect midpoint with the ruler, and then find the perfect midpoint of B prime, and you connect them with a straight edge, boom, you have your line of reflection. Ruler, midpoints. The last one is using the last tool that you had. You could use a protractor, and you could draw a 90-degree angle at a midpoint. Let me get a fresh screen to show you how you would do that. So pretend that this is A prime. You found the middle. Let's say you don't have any other points. Okay, you want the line of reflection for just these 2 dots. Then you would take your protractor, and you would set it on here, and you would measure, this is where 90 degrees is. You'd put a little tick mark where 90 degrees is with your protractor, and then you'd get your ruler, and you'd make sure to go through that tick mark and through the middle. And so that's the 3rd way. There's 3 ways. We love having options, right? Options are good. So you pick whichever way you're more comfortable with, and you are allowed to use those ways. Whichever one you are more comfortable with, okay? All right. Now, the story changes when we're on the coordinate plane, because we can find the line of reflection even more precisely. We can be perfect on the coordinate plane as long as all of our points are on integers. But anyways, we can be perfect because we can use what we know about coordinate geometry. So let's talk about how we would start this. We're going to start it like we did all the other ways, and we are going to we're going to connect the dots. So let's do it. Let's connect the dots. Okay. Now, instead of using any of your tools, I don't want you to use a single tool. I want to use coordinate plane only. Now, how would I find the midpoint between x and x prime? You could use the midpoint formula with the coordinates, or you could do it the easy way where you just count the rise over the run. I rise 6 and run 6. So the midpoint would mean I need to rise 3 and run 3. So boom, there's our midpoint. It's at -4, 4. So I just went halfway up and halfway to the right. Half, half, okay? Or you could have used the formula. All right, so what did we do so far? We found the midpoint. I'm using that abbreviation for midpoint. Now, we need to draw a line that's perpendicular to x prime at the midpoint. So we want to be perpendicular to x prime. And do you remember how to do that? What's true about 2 slopes if they're perpendicular? Yay! You have to find the opposite reciprocal. Very good. So what is the slope? What is the slope of x prime? Well, if you rise 6 and you run 6, then the slope is just 1. So now I want to be perpendicular to 1. And the opposite reciprocal of 1 is actually -1. So what we're going to do is we're going to start at this point right here. And we're going to go down 1, over 1, down 1, over 1. Not over, but right 1, sorry. Down 1 to the right 1. Down 1 to the right 1. Down 1. And technically I only needed 2 points to create a line, but I did more just to be safe. I'm going to get my ruler back out. Pretend this is my ruler. And now we have the perfect line of reflection. Okay, so it's actually a 4th way. You now know how to find the line of reflection 4 different ways. Cool. Ooh, that is the line y equals -x. It is in this case. Yes, it is. Okay, very good. Next one, I want you to try it. Write the equation for the line of reflection. Go, try it. So we know that the line of reflection is going to be the perpendicular bisector of the segment that we get when we connect the vertices. Now, we got lucky on this one, right? So we need to find a midpoint and we need to find a slope. But on this one, when we find the midpoint of B prime, rise 4, run 2. So I'm going to rise 2 and run 1. When we find the midpoint, it happens to also be the y-intercept. That won't always happen. So the y-intercept is 0, 4, right? I'm going to let you just write 4 for the y-intercept, okay? Now we need to find out what that slope is going to be. The slope of B prime, slope, is rise 1, 2, 3, 4, go backwards 2. So the slope of B prime is negative 2. We want our line of reflection to have the opposite reciprocal slope. So the line of reflection slope is going to be 1/2. Fall 1, run backwards 2. Fall, run backwards 2. Okay. And super easy. Once we know the slope and the y-intercept, y equals mx plus b. Writing the equation of the line is easy. I will make sure that your lines of reflection always have an integer y-intercept, so it'll be nice. Okay, this one is a little bit tougher. This one's a little bit tougher. Let's see how we can do this. We want to reflect ABC over a weird line, not a horizontal line, not a vertical line. Y equals negative 1/2 x plus 3. So first, we need to graph that line. Always start with your y-intercept. Go up 3, put a dot, and that's your starting point. From that dot, now we can fall 1 and go to the right 2. Fall 1 and go to the right 2. Fall 1, right 2. Fall 1, right 2. Or we could rise 1 and left 2. Rise 1 and left 2. Okay? So we have now graphed the line of reflection. They told it to us. Now our job is to take that triangle and flip it over the line. Flip it. We're going to use what we know about the line of reflection. Let's flip A first. I want to reflect point A over that line. Well, I know that A prime is going to lie somewhere on the line that's the perpendicular bisector, right? Or that line that A prime is going to lie on is going to be perpendicular to the purple. So what is the slope of the purple? The slope is negative 1/2. What about the perpendicular slope? Let's be perpendicular to that. It would be 2. So what I'm going to do is start at A, and I'm going to use a slope of 2 until I make it to my line of reflection. Are you watching? Use a slope of 2. Down 2 over 1. Down 2 over 1. I made it there. I made it to my line of reflection. How many times did I have to do it? 2 times, right? Down 2 over 1. Down 2 over 1. So I went down 4 and over 2, but no matter. I'm going to do it 2 more times, and I will end up in A prime spot. Down 2 over 1. Down 2 over 1. And I eyeballed that line really incorrectly. This is A prime right here. So what did we do? We found the slope. We found out how many slopes it took to get to our line of reflection, and we did that many slopes again. Okay? Super technical here. All right. What about B? Let's see how many times it takes to get to our line of reflection. Down 2 over 1. Down 2 over 1. Down 2 over 1. It took 3 times. So starting at the line of reflection, we're going to go 3 more. Down 2 over 1. 2, 3. And there is B prime. So if I connect the dots, we didn't have to do C, hallelujah, right? If I connect the dots, I now have my reflected triangle over the line y equals negative 1/2 x plus 3. Flipping our paper over, we are now going to do advanced rotations, which is actually going to be easier than what we just did. That one was probably one of the hardest ones that we just did. So let's rotate about all different points. First, we're going to learn how to determine the degree of rotation. We're not in Kansas anymore. It's not just going to be 90, 180, or 270. It can be all different degrees of rotation, and that's why you have a protractor. All right, let's discover how to find the degree of rotation. So first, we're going to connect C and C prime to the center of rotation, which in this case, we're going to still use the origin. So use your ruler, connect C to the origin, connect C prime to the origin. You're going to find that you're going to need to extend that line. So use your ruler and make this much longer. Using your ruler only. Measure the angle formed by the segments. That's easy. So what you're going to do is set your protractor right here with the middle of your protractor right there. You have to line your protractor up on one of the two segments, whichever one the shorter one is. That's what you can put your protractor on. And then the longer one can be the one that goes through all the numbers. Don't tell me what you got yet. Just measure it. Good. I also got 50 degrees. Now, on a quiz, I would always give you a buffer. I would accept anywhere from probably 47 to 53. You know what I mean? So I would give you a buffer. It's 50 degrees, though. I did this shape in Sketchpad, so I got to tell Sketchpad exactly what angle I wanted it to be. So the true answer is 50 degrees. Okay? Let's do another one. Find the degree of rotation. You're going to start this one the same way as you did last time. We don't need a coordinate plane to find the degree of rotation. So we're going to connect, I'll do it with my line this time. We're going to connect H to F prime. Connect H to F. Don't you wish you had one of these tools on your paper? Oops. And measure the angle. So you're setting your protractor down right here. And you're measuring whatever number you're seeing right there. This is an acute angle, so we're going to use the set of numbers that are smaller, but then we'll subtract it from 180 to get the clockwise one. I can't believe I said it was acute. It's obtuse, obviously, people. Sorry, it's totally obtuse. Pick the other number. Picking the wrong one. Stanton's going crazy. It's obtuse. Pick the other number. Yes. My bad. So you had a choice of 110 or 70, and I led you astray. 110 is the right answer. Now, that's the counterclockwise answer. What would the clockwise answer be? We did this on the whiteboard yesterday, remember? What would the clockwise answer be? So that would mean from here to here. How many degrees is it? $250? Yep. 360 minus 110. All right, we need to keep going. Okay, we have a couple more things. How to rotate a shape with a given center. So we want to rotate, well, this isn't a given center, it's actually a given degree. Anyways, we're going to use the center as the origin, and we're going to rotate this triangle 60 degrees. We're going to rotate this triangle 60 degrees. What do you think we do first? Surprise, surprise. That's what we always do first. Connect the dots. Let's only rotate one point at a time, so don't connect all of them. Don't connect E and F and G. Don't do it. Just connect E. So I want you to take your ruler and connect E to the origin. Then I want you to put your protractor on the origin, like this, with the center here. And what do I want you to do with that protractor? I want you to measure a 60-degree angle. So wherever the 60 falls, wherever the 60 is, somewhere like you put a little tick mark, and then you just connect the dots. I just eyeballed that. That might not be how it really looks. So you put a little tick mark where the 60 is, and then you connect them. Now the question is, where does E go? Because I know E prime lies somewhere on that pink line, but where does E prime lie on the pink line? Now, when the numbers are pretty, you could just count the distance. You can count the rise and the run, and they're integers, and it works out pretty. But it's not always, the coordinate is not always going to fall on an integer. So instead of using the coordinate plane, yes, Ton, you could use a compass, very good, or you could use a ruler and measure it. I love the compass answer. So I'm going to do it the compass way, but if you want to do it the ruler way, you can do it the ruler way. So I'm going to put my needle on the origin. I'm going to put my compass on E. And this is easy. I just go over here, and my line might not be perfect. Yours will be perfect. Mine might not be perfect. But where that arc intersects your line, that's where E prime goes. What did y'all get? Did y'all get a pretty coordinate for E prime? Yep, I'm getting -3, 5 on my paper. -3, I was almost there, but I didn't draw my line correctly. This is E prime. Okay. Now let's do it with F. Okay? Step 1 is you need to connect F to 0, 0, because that's your center of origin. Connect F to 0, 0. Now, we need to take our protractor, and we need to measure a 60-degree angle. You need to line your protractor up with F, the segment. Should probably get my real protractor out on the smartboard. Anyways, so you line your protractor up with that segment, and you measure 60 degrees. And you put a little tick mark. Should be right here-ish. Okay, you draw a line. So that line represents a 60-degree angle with the origin and F prime. Okay, now we need to know how far away from the center of rotation F is. How far away is it? And we can use a ruler, or we can use a compass. We can use a ruler, or we can use a compass. So I'm going to put my compass here. I'm going to open it up to F. And my compass is now telling me it's measuring, quote unquote, how far away F is from 0, 0. So I want F to F prime to be the same amount away. So I'm going to make a little arc, and that is about where F prime would fall. So we're going with -3. Yeah, we're going with -310 as the right spot for F prime. Okay, so you would do the same thing with G. I am going to warn you, when I did G on my paper, I did not get a perfect coordinate. It's going to fall somewhere between 2 and 3, and then about up 8. It's going to fall somewhere right here-ish, but it's not a pretty coordinate. It doesn't fall on whole number coordinates. Okay. How to determine the center of rotation when you don't know it. All right. So this is the ugliest one. This one's rough. Just stick with me. This is the last thing we're doing today. Connect 2 points on the preimage to the corresponding points on the image. I only want you to connect 2 of them. Only 2 of them, or your picture is going to get too messy. So you can watch, or you can do it with me. It's totally up to you. I'm going to connect H to H prime. I'm going to connect F to F prime. The reason I'm only doing 2 of them is because my picture's about to get messy. Now I need to construct the perpendicular bisector of both segments. These segments are not parallel. They are not going to have the same perpendicular bisector. So I'm going to have to construct, 2 perpendicular bisectors. And the way we do that is the needle here. It's not letting me. I'm going to have to do it from my computer because it's snapping. Okay. Man, it is not letting me do this, guys, so just bear with me. There we go. Okay. We do this, and then we flip over. We do that. And connect them. So I have now constructed one of my... Hard to do this on the smart. Okay, trying again. I wonder if it's going to let me open it more than half. It's going to go off the screen. You know what? Maybe we should omit this part. Oh, no. See how messy this is getting? So I'm going to pretend that that did not go off my screen. And I'm going to eyeball it once again. So I'm connecting these. And the point at which your perpendicular bisectors intersect, whatever that point is, that is the center of rotation. Woo! Do you see how it says K only at the top? That is there for a reason. I don't need to use G because when two lines intersect, that will be the center of rotation. I don't need a third line because it's going to intersect the other two in the same spot. So I don't need that third line, and can you tell how messy the picture was already getting? So I didn't need to use G. Yes, it will. If you haven't left yet and you're doing this last one, this one when you have multiple choice of different centers, this one's easier, okay? So on this one, I can just connect two of the dots. When I'm not having to draw the perfect one myself, I can just connect two of them, and I know it's going to lie on the perpendicular bisector. So all I have to do, I could probably eyeball which one's going to lie on the perpendicular bisector, right? But if you don't want to eyeball it, you only have to construct one, because once again, we have multiple choice here. So I only have to construct one perpendicular bisector, and the answer is going to fall on the perpendicular bisector. Now, you're going to run into trouble if two of them fall on it, but I don't think we're going to do that to you. Okay. What's the answer? The answer is A. Okay, so what did I do? I connected 2 points that were corresponding. They went together. I constructed the perpendicular bisector, and only one of those points fell on that perpendicular bisector. Tomorrow, the quiz is actually over this kind of stuff. It'll be like multiple choice. You'll have to construct things yourself, but there'll be different answers that you can choose. You know what I mean? So do tonight's homework and study tonight's homework to get ready for tomorrow's quiz.